Okay, here we are with our schematic, and I wanted to go over a couple things here real quick, and that is the power supply. As you can see, here's our 125 volt input, our main power switch, our fuse, and a little 0.02 microfarad capacitor that's rated at the line voltage. Typically it's going to be 400 volts. I think I omitted this from the BOM. In any event, this is the main power transformer, and for instance this is our 6.3 voltage here for the two preamp and the final amp tubes, and that's the 6V6 and 6SL7 as notated right here. Also we have a 5 volt winding, and that's what operates the filament, and this is typically going to be the filament designation on the schematic for people that don't understand tubes yet. You will here right now, and pretty much this little pointy looking thing, it's usually a upside down V or something like that. That's the filament. That's the hot wire, the heater. That's where your electrons come from. And on pin 2 and 8 is where the two wires get connected, and then off pin 8 traditionally is where, believe it or not, your what we call B plus or DC voltage comes out. On pin 4 and 6 is your high voltage winding, and notice that it has the center tap on the 6.3 and on the high voltage winding. The center tap goes to ground. That's what these insignias represent. So this is how we're wiring it up. We're going by the schematic here, and I've done some wiring, and we'll look at that here in a second. Also, just a note, there's a filament pilot light represented by this nice little number here, and these are pretty cool looking. You can get them in faceted lenses, all kinds of different things to make your amplifier look really nice. So briefly, let's just keep on going down here. These are the 450 volt power supply capacitors. These are the electrolytics that filter the now pretty ripply, goes in AC, comes out DC, down this line. They tend to have a pretty good, almost AC looking waveform. After they proceed through to ground, which is the same ground here, everything's the same ground. Then there's a small resistor, and then we have what's called B1, another resistor and cap, and then B2. These are the different high voltage supplies. They keep getting a little lower and lower. And then B3. As the amplifier progresses through the schematic from the input, and we'll go through that in a second, to the output, the voltage gets higher. And this actually gets connected straight to the output transformer. So these resistors here, by the way, just for your notation, I've ended up including a high wattage specification. That's not necessarily needed. I got away in this circuit with just a 1 watt resistor in these locations, but I can update the BOM. But in any event, when they're a little bit bigger, they're a little bit easier to use. They're a little bit more expensive. So what? So, okay, I'm going to move the schematic here. Please excuse any jittery action. Okay, so here is the input from your guitar, and of course the shield goes straight to ground. It goes into what we call the grid or the screen directly, and then comes out the plate. Sometimes it comes out the cathode. In this case, the cathode is grounded with a network of a small little parallel component a resistor and a capacitor. These you can change quite a bit, but in one case that is always true. What we use eventually, just temporarily, is a 1 ohm resistor located right below these two, connected to ground. We measure across that 1 ohm resistor in millivolts with your voltmeter, and that represents, directly converts to milliamps. That's pretty handy because that tells us how the tube is biased. Now this is a dual triode amplifier, thus the name of each tube and it has different pinouts. So this is one tube here, and I believe I call it A and B. Both plates get a resistor to ground. Both cathodes get a resistor to ground. You can also play with this value here with a capacitor next to it. And over in this area here, I've included in this area here what a typical rotary switch will look like, and a note to say where this wire will go, which will be basically reproducing this pair, but being able to switch out that pair or just a single resistor in different positions on the rotary switch, and it still goes to ground, as you can see. So you can play around with different pairs of resistors, capacitors. I go from a 4 mega ohm all the way up to, I think, 22K, which is 22,000 ohms. So in any event, what I've done here is, and I'll show you in a second, is with these older transformers, you know, these used to be rated at 117 volts. Now we're up to about 124 volts. This 6.3 volts, when it's loaded, correction, this 5 volts, when it's loaded, actually lighting up the 5 volt rectifier tube, which is the only place this 5 volts goes to, and also it serves as the what we call B plus to the rest of the high voltage needs. At 125 volts, it's up to about 6 volts, where the tube's not going to live very long at all. So I had to install some resistors on that line right here, and I'll show you those. Also, the 6.3 volt line, I had to install some a resistor, actually 2 in series, and I use 0.82 ohms. They're large white kind of ceramic looking things. Why I like them is they have a lot of flat surface area, so I can tend to super glue them to the inside of the chassis once it's wiped with alcohol, and I've never had one come off. So that's how I dump this excess voltage. What is also a nice thing is that this area here, I end up with a little extra voltage, and I've never had a transformer fail from this 117 to 125 jump. So instead of 600 volts, I end up with almost 700 across this, which is kind of a nice thing. The capacitors, being 450 volts, they aren't going to live long. So what I end up doing is putting 2 in series. I'll put another capacitor in here right next to the other one, with the negative connected to ground, the positive connected to now this negative, and then this positive connected to this line, this wire here. So I have 2 in series and capacitors, and that guarantees me that I'm not going to have a capacitor failure. So, having said that, excuse me for just a second. I have to play cameraman also. Go ahead and zoom out here. We'll have a look at what I've done so far. And I want you to take note how the green twisted wires are run. Now, what the heck? And I may have to go ahead and just double check my focus. And I'm going to put something in the back here to prop this up so we can have a look inside here. And I'm going to zoom in here just a second. Now, you see, I've installed pretty much all the parts. This is going to have to be a little intuitive on your end. I just don't have the camera and the production facilities to really go through each connection. But let's just look at this here. I have a red pair of wires here, and they're twisted because AC needs to not emit noise into the input of the guitar, which is over here, and this is why we have the preamp tube. These are the very fine signals that we don't want to be allowed to be corrupted by, for instance, this AC right here, and that's why the pair are twisted. They're twisted pretty tight, as you can see, and they're also mounted very close to the chassis and run into the corner. I don't know if you can see this, but this goes all the way into the corner. And I just use a little dot of super glue to hold them in there. So they come off here. They're actually soldered upwards into the prong to make sure that the wire exits down low, and it's just tacked in the corners along the way. It comes out here again, goes into the correct pins, which are notated on the schematic. For instance, the 6L7, it's 7 and 8. They're right next to each other here. And the way you look, I don't know if you can see the key right here, it's clockwise. Pin 1, 2, 3, 4, 5, 6, 7, and 8. On the schematic, it shows the filament for the 6SL7 to be pin 7 and 8. Also over here on the power tube, the 6V6, it's going to be pin 2 and 7. So here's the keyway, pin 2, pin 7. And I've split the harness and retwisted it, as you can see, with all the care in the world, tacking these down with a dot of super glue to keep them as close to the chassis to pick up the emitted RF from the AC, even though it's only 6.3